In this section, we're going to talk about increasing, decreasing, and constant for a function f of x. So we're going to start with the three textbook definitions and look at how they work. We say that a function is increasing on an interval if for every x1 less than x2, okay, so this is kind of important here, x1 less than x2, that means that we're going from left to right. Okay, x1 is less than x2, going from left to right. We have f of x1 is less than f of x2. Okay, so our starting value is less than our finishing value. Looking at the graph, we can see here's x1, f of x1, here's x2, f of x2. And we see that in this interval, our function values are continuing to get larger. So our initial function value is smaller than our ending function value, and that's true for all of the x's in that interval. So we say that this function is increasing, which should make sense because in English we say increasing for things that are getting larger or going up. And we see here as we go from left to right, this function is going up. We say decreasing on an interval if for every x1 less than x2, so that doesn't change, we always want to go from left to right. We have that f of x1 is greater than f of x2, so our starting value is bigger than our finishing value. So we see here, here's f of x1, and we're going down to get to f of x2. So as we go from left to right, our function values get smaller, and that is a decreasing interval. And again, that makes sense. In English, decreasing means to get smaller or lower, and we see that here we are going down. Constant we don't see as much, especially in terms of functions. We do see the constant function, which is a horizontal line, but generally within a function, we almost never go completely horizontal. So this one we're not going to see as much, but it is part of the set of definitions. So we say that it's constant if for all x1 and x2 on the interval, doesn't matter what the order is, because we have f of x1 is equal to f of x2. So that says for any x values in the interval, our y values are going to be the same. The y value does not change. So looking at our picture, we can see here all of our y values for these points are going to be the same. That's a constant function and a horizontal line. Okay, so if you see a horizontal portion of your graph, then that's going to be a constant interval. Be careful with this because some graphs look like they go horizontal, but they very rarely do. So you need to make sure that it's actually horizontal for that section of the graph. Most often we see increasing and decreasing. Now when we do this, we're going to write this as intervals, and the intervals are going to be in terms of x. So we would write this as x1 to x2, this one, x1 to x2 the same, and then down here, okay, that part doesn't change. Now, in this edition of the book that we're working out of, they use square brackets for increasing and decreasing. The old editions of, I think it's Sullivan, used open brackets. They didn't include the endpoints. That's the way that I was taught as well in pretty much every math class I took. This is a less common convention, and I'm not totally sure why they switched to it, but I'm going to try to be consistent with the book and use square brackets for increasing, decreasing. If at some point you see open brackets, I'm not trying to be tricky. It just means that either it's a question that I wrote from a previous semester, or I just forgot and did open brackets because that is what I'm used to, and many years of doing it that way, I probably forgot and wrote open bracket. So in my math lab, in the homework, you are going to use closed brackets, unless of course it goes to infinity. Infinity is always an open bracket. So let's take a look at an example. Let's take a look at this example and see if we can determine where it is increasing, decreasing, or constant. Some things to remember as you are doing these. One is that you always have to go from left to right. And in doing so, you really need to ignore any arrows that are there, because sometimes the arrows will deceive you. So for example, on the left here, this arrow is pointing down, which makes you think decreasing, but it's not. So we're going to see that in a second. Just ignore the arrows and always move from left to right. And then the last key thing that you need to remember is that it's always going to be in terms of x values. Okay, we're always in terms of the x values for the interval. All right, let's look at this example. I'm going to put my infinities on here because remember that we're moving from left to right. And we're going to go along this just like it's a roller coaster. So starting from the left, we're going to ignore this arrow because it's pointing down, but that's not true. Going from left to right, we are going up. We are going up. And up, we remember, is increasing. So we are increasing along here. Okay, it goes forever in this direction, so that means we go all the way out to negative infinity. So we are increasing from negative infinity to 1, looking at the x values. Negative infinity to 1. Infinity is never included. For this edition of this book, 1 is going to be included. Next part, going from left to right, we're going down. So we are decreasing from 1 to 3. Again, only the x values. And then the last part, we are increasing, we're going up. So we're increasing again from 3, and it goes forever. So we're going to go 3 to infinity. 3 to infinity, like that. Okay, so you go from left to right. Ignore what the arrows are telling you. Go from left to right and give the x values as you go up and down. We don't have any flat parts to this, so there's no constant in this one. Okay, let's try one more. All right, let's say this is negative 4, 0, negative 2, negative 2, negative 1, 0, 0, 3, 5, 0. Smooth this out just a little bit from the original picture. Okay, let's say this is our picture. We want to figure out increasing, decreasing, or constant. Again, we go from left to right. So we're going to ignore this arrow. The first part is actually going down, so we are decreasing. And now what sometimes throws people is, do I stop here? I'm given this point. Do I stop here? And the answer is no. I keep going all the way to here. I am decreasing over that entire interval. That negative 4, 0 is given to us as a point, but it has nothing to do with the increasing and decreasing. I don't want to stop there. If I stop there, that might imply something like a break in the graph or an asymptote or something like that, and I don't want that. I want to go all the way from here to here. So I'm going from negative infinity to negative 2 for decreasing. So again, infinity is never included, and I go to negative 2 for my x value. Then the next part, I'm going up. Again, I don't stop here. That point's given to me, but I go all the way to here. I go up all the way to here. I am increasing from negative 2 to 0. I don't need to stop at that point just because it's given to me. Maybe it's given to me for another part of the question or something like that. So I go all the way from negative 2 to 0 for increasing. And then the next part, we're going down. I'm decreasing. So I'm decreasing from here to there, from 0 to 5. Decreasing from 0 to 5. And remember, we write our intervals the same way that we're going through this from left to right with the x values. So I go from 0 to 5. I do not want to write this as 5 to 0. That would be bad. Last section, I'm going up. So I'm increasing forever, 5 to infinity. 5 is included, infinity never is. So again, run through your problem real quick, left to right. Make sure that you got all of your intervals, and you're done.